Hello! In this video we're going to talk about how do we identify and solve for x and y intercepts from an equation, and we'll also talk about how we write increasing, decreasing, and constant intervals from a graph. Let's start off with finding y-intercepts. Since x equals 0 to y-intercept, all you have to do is find f of 0. So let's say you're looking at f of x equals negative 2x cubed plus 4 over 3. If I want to find the y-intercept, I just change all the x's to 0. So after I do that, so f of 0 is going to equal, this just went away, 4/3. The y-intercept we can say is at 0, 4/3. Alright, for x-intercepts, which again can be called roots, zeros, or solutions, all we have to do is set y equal to 0. So let's say we were looking at a problem that said find the roots of 2x squared plus x minus 15. I'm going to replace the y with 0, and now to solve this I'm going to have to factor. If you don't remember how to factor something like this, feel free to pause the video, go to Khan Academy, type in factoring, there's plenty. But this is going to factor down to 0 equals 2x minus 5 times x plus 3. And now to solve, we remember that we set each factor equal to 0 and solve, so x is going to equal 5 over 2 and negative 3. So my x-intercepts are at 5 halves, or 2.5, 0, and negative 3, 0. All right, increasing, decreasing, and constant. What we want to do are find the intervals where this function is increasing, find the intervals where it's decreasing, and where it's not changing, where the y values are not changing. That's constant. Things to remember, we're going to be doing these with interval notation, and we are never going to use brackets, okay, because at a point like this, you cannot be increasing and decreasing at one single point. All right, so let's find the values where this function is increasing. So we read from left to right, and don't pay attention to the concavity of these parts of the graph. Just think, are the y values increasing? So as this arrow goes off to negative infinity, it's increasing from negative infinity until it gets to negative 5. See, at negative 5, it starts going down again. So we're going to say to negative 5. And then I check, is there anywhere else that it is increasing? And yes, here at 5, it starts increasing again. So we're going to union this from 5 to infinity. It's decreasing on the interval from negative 5 to negative 2. So again, even though we're looking at whether or not the y values are going up and down, our intervals are the x values. So from negative 5 to negative 2, it is decreasing. And where is it constant? Between negative 2 and 5. And really, increasing, decreasing, and constant is as simple as that. All right, that's all. Goodbye.